The groups of the coils are assembled for the magnetic suspension faceplate. The first layer should be binded with a solenoid coil going one direction like a linear motor. And it should travel up an aluminum surface exterior. And its bearing should be localized on iron so it can magnetize the iron and create a better magnetic field. A greater magnetic field. That's the first core. The outer core of that is aluminum sheets, iron encasing copper sheets. So when you see a coil, a copper coil, bearing a rod, an iron core rod within it, and it's extended from the coil bank. What happens when you put aluminum rings on there? It will fly up into the air because of the iron rod that is magnetized. The winding, electrical energy winding field will move alongside that to move the aluminum to its place, which is this. Now, what I did was I introduced it with copper. Now, copper aluminum, looking at another footage that they had on YouTube, where a gentleman, scholar from a college in London, he took a coil, how can I say, a cylindrical armature copper and placed it local to the electromagnetic field bearing the aluminum, and there he received a reaction type to where it started torquing and turning the copper freedom for rotation ball bearing on a bracket. He had it handheld local to the electromagnetic field, the winding energy, and the aluminum ring that was alongside the exterior of the iron core of the electromagnetic coil. So therefore, he had the coil going one direction. So it wasn't suspension. Now here is applied to the frontal, and that is mounted onto the frame. Then permanent magnets are localized on here. So that's what I did differently. And though I have the coil going in one direction, and I apply it here, the iron core, and then for here, I apply another iron core bearing copper into a copper core of iron, and I apply that to the surfaces of the coil. Then the following is applying the copper coil alongside it to make a solenoid sense pull and push, so that the movement of such a device can oscillate up and down, and the electromagnetic field causing it to move up and down. So even though it has solenoid sense, you have this one is push and this one is pull, so it will enable it to suspend in the air. So that's how the framework that's how the subsystem would work of the Iron Man suit system, of the faceplate, and that's how it operates. So I'm going to stick this aluminum, try to get this on with one hand. I only got one hand, so give me a break. And to try to apply this to the 3D print onto the surfaces. Now, I only have one hand to do all that, so I'm not going to do that right now, because I know that before that, the first coil that goes up is the suspension coil, and then comes the iron, and then comes the permanent magnets, and I got to apply all that in order to get that buoyant in the air. I'm still working on the omnipopper, which just uses electromagnetic repulsive force to move it forward. So while it goes local 2, it will move the frontal forward, both using eddy currents and push force, only push force parallel one direction, push force, repulsive force against the permanent magnet, and causing the permanent magnet to move forward. So that enables it to oscillate up and down and back and forth. Where the magnetic field is right here, that's why it's not allowing it to turn towards it. This one right here too. So even though there's a permanent magnet within the core, it's not allowed to get to it. That's okay. I got a capacitor here for tasing, but I'm going to finish constructing that. I'm just going to show you this, how a voice coil may work without wrapping it directly all the way around the faceplate when using it in a biometric range. My name is Jermaine Morton. Have a nice day. Goodbye.